still be on it. I'm going to change it so that there's going to be no faces on it, but I want to record just in case people aren't able to show up, and I can post it for them to watch after. Okay, so let's take a look at this 8th grade assignment for today. We're looking at our warm-up. So if we look at, I'm going to walk around to the board because I'm going to be writing on the board. And I'm going to swap my camera around so that you can see me a little bit better. Maybe you can see my feet, who knows. We have this warm-up here, and I'm going from this smaller blue shape here to this larger green shape here. And let's think about what type of scale factor this is going to have. What could be an example of a scale factor that this drawing could have to go from the blue shape to the green shape? Can you throw that in the chat for me? What sort of scale factor? Take a guess at the scale factor that we could use for the blue shape going to the green shape here. What do we think? A 3? Who is that?
Joe.
Joe, awesome. Nice job, Joe. So Joe said a scale factor of 3. Mila actually said the same thing. And Mila, or Joe, why don't you tell us, why do you think you picked the number 3?
I picked the number 3 because I counted each kind of like point on like where it's supposed to go. And then I just placed it on point A. A prime, and then I got the and I just placed it there, and I got 3.
I love it, Joe. And you want to know what I like that you did is you actually took this one step further than I was expecting people to do. You actually counted the number of circles out. A was from P, and then you looked at what number do I have to multiply that distance by to get it to where it would be A prime. Good. And we can say, you could have also said an example of the scale factor could have been 2 or 4 or 9. Any number that's larger than 1 could have been the scale factor for this one, because what happened to the shape when we went from blue to green? What did we notice happened? Throw it in the chat.
It got bigger.
It got bigger, yes, exactly. Because the shape got bigger, because we went from the blue one to the green one, it got bigger. We're going to need a scale factor that's larger than the number 1. Awesome job. Nice job. So now if we're looking at this one over on the right side here, we're going from this larger shape here to this smaller green shape here. What do we think, throwing in the chat, what do we think could be a possible scale factor that we could use for this one? You're not going to be able to find the exact one because this was a little bit challenging, but what could be a possible scale factor?
2.
So Landon said 1/2. Who was that just called that just spoke? Was that Joe again?
Edgar.
Oh, Hector.
No,
Edgar. Edgar said 2. Okay, let's have some more friends put it in the chat. Rashem, what do you think could have been the scale factor for the blue one to the green one on the left here? Also, Destiny, what do you think could have been the scale factor? Jalen, what do you think could have been the scale factor? Throw them in the chat for me. I'm not going to give us what. Okay, go ahead.
I put 4.
4, okay.
Yeah.
But we're going from a larger shape this time to a smaller shape. So what did we think? Nice job, Rashem. Thank you, Melissa. Thank you, Tiffany, for throwing things in the chat. So when we have a scale factor of, for example, 2 or 3, that means my shape is going to go from being smaller to being larger, like we had in that example to the left side. But this one on the right, we're actually getting smaller. As I do my dilation, the shape is getting smaller. So if we remember back to the types of scale factors that would get me there, we would have to have fractions like Landon was saying. So we could say we had a scale factor of 1/2. What's another fraction that we could use for our scale factor? What's another fraction? Any fraction. Throw some in the chat. Destiny, throw a Nice job, Tiffany. Nice job, Rashem. So Rashem and Tiffany said the same one. They said 1/3. I love it. You could also use 3/4. You could use 17/18. That would still be a fraction. So the scale factor in the drawing would get smaller as we do our dilation. Good. Nice job, guys. Awesome, awesome, awesome. Nice job. And I love how people were really brave and threw answers in the chat and unmuted themselves and spoke. I love it. Let me let Shelby in. Okay, so let's take a look. Our task for today, we're doing 3 things. We're finishing up reviewing activity 2. We're going to do the 3rd activity using the applet, and we're going to review the notes and complete the exit ticket. So if we're looking at task 1, we're going to review the 2nd activity. So if we're looking at this guy here, if we're looking on slide number 5, this was the activity that we did in class for a majority of the time, where we had this original blue shape, right? And then we dilated it by a scale factor when we went from the blue one to the outside green one. What did we say was our, if we remember back, what did we say our scale factor was for that one? Throw it in the chat for me. What did we think that the scale factor was for that blue one to the larger green one? It wasn't 3, but it was, we had a scale factor of 2, right?
Yeah.
Very good. Nice job, Edgar. We had a scale factor of 2. Nice job, Tiffany. We had a scale factor of 2. So what did we notice when we multiplied by a scale factor of 2? What did we notice happened to our shape when we did that?
The shape got bigger.
The shape got bigger. Very good. So what did you notice about polygon EFGH was that it got bigger. What else did we notice? We noticed that it got bigger, but it also stayed the same in what way? Jalen, what do you think? How did it stay the same though? Do you remember?
It just like, it's like stayed the same like size and everything, but it just like moved itself like either smaller or larger.
So it made itself either larger or smaller, and Jocelyn tagged onto that and she said shape-wise, it's the same shape. Very good. And I think that's what you were going for, Jalen, there. It got bigger, but it stayed the same shape. So let's get this written down, because when we have a scale factor of 2, we're going to notice that it's going to get bigger, but it's still going to stay the same shape. Good. Now let's compare what we did with this blue original figure, but now let's look at that smaller shape, IJKL. What did we say our scale factor? What did we use for a scale factor when we made it smaller like that? What did we think? Nice job, Mila. We use a scale factor of 1/2. Very good, Mila and Tiffany. So we use a scale factor of 1/2. So what did we notice about this new shape, IJKL? Throw it in the chat, or if you want to unmute yourself, you can.
It got smaller than the rest of the other shapes.
Good, it got smaller. And what is the other observation that we could make? It got smaller, but what stayed the same?
The shape.
The shape, very good. The shape stayed the same, but the size got smaller. Very good. The shape stayed the same. Very good. So we notice that when we are multiplying and doing a dilation, it either makes it larger or smaller, but the shape of the object still stays the same. Really good job. Nice job. I'm going to keep that up for another minute so that you can copy it down if you didn't get it. And then we're going to take a look at the next piece of this activity here. Okay. I'm going to keep it up for another 10 seconds so that you can copy it down if you didn't get it. Okay. So let's take a look at slide number 6 now. Slide number 6, we're gonna use the computer to do another dilation here. We're gonna be looking at task number 2. It's not a card sort. We're actually gonna be doing this activity here. I'm gonna come around to my computer so that I can show you what I need you guys to do on your computers as well. So what I need you guys to do now is, I'm going to mute this chat. And so we're looking at this and we need to dilate polygon EFGH using Q as the center of dilation and a scale factor of 1/3. So what I need you guys to do is I need you to click on this picture, the picture here, and it's going to open up a link just like I did here. And you're going to scroll down to where it says quadrilateral. Actually, it's going to be 2.4, I believe. Sorry. You're going to scroll down to the 2.4 where you see this shape right here, a quadrilateral and concentric circles. So we're going to be looking at this app right here. And it says we need to dilate polygon EFGH using Q as the center and a scale factor of 1/3. Okay, so the image of vertice F has already been put on here and it's been labeled A. So we're going to need to dilate this G by a scale factor of 1/3, H by a scale factor of 1/3, and E by a scale factor of 1/3. Let me show you how we're going to do that. So on the slideshow for today, at the bottom here, I put some dilation boxes for you. In the first box here, you're going to write the point that you're going to be dilating. So we're going to look at G first. And we're going to do the same thing we did in class. We're going to find the distance for that point from the center. So if I come back to my page here, I need to count the number of circles out G is from my center Q. And it's 1, 2, 3, 4, 5, 6. So my distance here is going to be 6. And I'm going to multiply that by my scale factor, which we said was what number?
1/3.
1/3. Nice job, Landon. So we're going to multiply by 1, divide it by 3, and then if you hit a space, it should turn it into a fraction. If you don't want it, if you want it to look like this, that's fine that way as well. So if we take this 6 and multiply it by my fraction of 1/3, what am I going to get for my new distance here? So it's going to be equal to numerator. So this is, we can write 6 as 6 divided by 1. Numerator times numerator, we would get 6 over 1 times 3 would be 3. And we have 6/3, which is equal to what number?
2.
2. Nice job, Edgar and Landon. Very good. It's equal to 2. So my new distance is going to be 2 circles out. If I come back to this page here, I'm going to click the point button and I'm going to count 2 circles out. And it might be a good idea to draw a segment on here so that we can put it in the right spot. So I clicked the segment button. I clicked on the center and on point G. I'm going to make one for here as well, and here as well. So I count 2 circles out, 1, 2, and I put the point. And now that is my new point, my dilation of point G. So now if I want to look at point H, let's count the distance. Well, let me see if there's something in the chat. No, we're going to count the distance from our center Q to that point H. How many circles out is it? 1, 2, 3, 4, 5, 6. On your slide, I want you to come back and I want you to put your distance in here. What is your distance as you're working from Q to that point H? Who can tell me what's the distance from Q to that point H? How many circles out is it?
9.
9, very good, 9, very good. And we're going to take that 9 and we're going to multiply by my scale factor, which we can write as 1/3. And if I write it as 9/1, I multiply by numerator, and I get a new numerator of what number? 9 times 1 gets me
9.
9, very good. And my new denominator, 1 times 3, gets me a denominator of
3.
3, nice job. And if I simplify that fraction, that's equal to what number? Nice job,
3.
Sam. Nice job, Edgar. 3, very good. Nice job. So my new distance for point H is going to be 3 out. So if I come back to this slide, this page right here, I'm going to count 3 circles out and I'm going to put a point. So I'm going to hit the point button if you remember. I'm going to count 3 circles out, 1, 2, 3, and I'm going to put a point and it's going to label it C. It's going to name it C. So now I want you to do the last piece independently. I want you to find the distance between Q and E, multiply by your scale factor, and then we can find the new distance for our copy or our image of point E. So we're going to come back here. We're going to label it E, our distance. Times our scale factor. So, Tiffany, do you want to unmute and tell me what was the distance that you found for point E from the center? Or you can throw it in the chat, Tiffany, either way.
3.
3, very good, nice job. So my distance was 3 circles out from the center, and I multiply that by my scale factor of 1/3, and I would get numerator, which is 3, times numerator, which is 1. I would get 3 over what number?
3.
3, nice job, Edgar. And that simplifies to what number?
1.
1, nice job, Edgar. So my new distance for E, nice job, Jalen, you got that one perfectly, would be 1. So if I come back to this page right here, and I count 1 circle out and put my point, it would fall right there and it would be named D. Now my last step, what do I have to do? My last step, we did this in class and you did this if you were at home. What was the last step you had to do with those 4 points?
Connect them.
Connect them. Awesome job, Rishem. So you're going to click that segment button and you're going to click on each one of your vertices. Awesome. So I have this new shape here. So now what I want you to do with this web page, let me just find the paper that has my picture on it. I want you to, on your Chromebooks, can you please hold and or click and hold the control, the shift, and then that button above the 6 that looks like this, the box with 3 lines in front of it, so that you can take a picture of that work. Okay, and then if we do that, I'm going to just do my snip tool this way. New. And we're going to take a picture of our work here. And remember, when we come back to our slideshow to insert that picture On the next slide, on slide number 8, you go insert, image from drive, and then it should be that first picture that you took, that first screenshot. Mine isn't up there because I'm not on my Chromebook right now, but when you paste it, it should paste your work in. Okay? Does anyone have trouble inserting or taking a picture of their work? No? Wonderful. Awesome job, guys. So we just did a dilation by a scale factor of 1/3. Awesome job, everybody. I'm so proud of you. So, oh, can I see page 7? Oh, so this is, so you want to see this one again, Sam? Oh. This is page 7. And then if you want, I can also go back to the IM tab as well. Let me see. Yes, perfect. Awesome. So awesome. Thanks, Sam. So we have our dilation here. We have our picture inserted. I'm going to go through and make sure everybody's picture got inserted. So make sure that by the end, if you didn't get it yet in there, make sure you get it in there. Now let's take a look at task number 3. So task number 3, if we look at slide number 3, or slide number 10, sorry, we're going to look at and we're going to talk about the important properties of a circular grid. So why do you think that we use a circular grid when we're doing dilations?
To keep track of like how many, like the steps and units.
Good, because it helps us keep track of the distances. Very good. For our, wait, that's not how you spell distances. So we use the circular grid so that when we have a dilation and it's the center, we always know where that center is, and we always know what we have to do with that distance. We have to multiply that distance for each one of the vertices by that scale factor. Awesome job, Edgar. So how does it help us to perform? It helps us keep track. So good, I'm going to control and I'm going to copy this in here because it's the same answer. It helps us to keep track of our distances. Okay. And then what do we think about as we go through? And if we slip and slide down to slide number 11, what do we notice about images, about new shapes, when we have a scale factor that's larger than 1? So I want you to take a few moments right now to, in your own words, tell me, what do you notice about an image when we have a scale factor that's larger than 1? Type it in, and then I'm going to have somebody share out in about 25 working seconds. What do you notice when you have a scale factor that's less than 1? Okay, so I'm actually going to have somebody specific read out their answer. So, Mateo, what do we notice about the new shape when we have a scale factor that's larger than 1? So, Mateo, you can either unmute yourself or you can throw it in the chat. What do you notice? Okay, so Mateo says he doesn't know. So let's take a look back at the examples from our slide number 5 here. So we said that this shape on the outside here was created with a scale factor of 2. Okay, and then we said that this smaller shape that fell inside here was created when we had a scale factor of 1/2. So what do we notice happens when we have a scale factor that's larger than 1, Mateo? What happened to that original image? The shape got larger. Exactly, Mateo. The shape got larger. And that's the main takeaway of this lesson here, is that when you multiply by a scale factor that's larger than 1, the shape, the original shape, gets larger. Good. And also, the shape stays the same. The shape, like the shape itself stays the same, but the size changes. The shape stays the same, but the size gets larger. Okay, so the shape itself stays the same, but the size gets smaller or gets larger. Good. Now, oh, sorry, go ahead.
I also noticed another thing that happens.
What else do you notice, Edgar?
Like more units are added, like more units like get bigger, and like the units, like more of the units are come.
Exactly, right? So the distance gets larger from the center. Very good.
Like it's hard to explain, but like it's added more of the units.
ADDED, more units. That's perfect, Edgar. I love it. So now I'm going to have, let's see. Let's try Destiny. Can you unmute and can you tell me what happens, or you can throw it in the chat. What happens, what do we notice when we have a scale factor that's less than 1? And I put some examples. I said 1/2 or 1/3. Destiny, what did you notice happened to it? Awesome job, Sam B. Yes, very good, Destiny. She said the shape, like the shape of it stays the same. But it gets smaller. That's perfect, Destiny. Exactly. Did anybody else notice anything different when they looked at an image of that had a scale factor less than 1? What else did we notice here?
More units are taken away.
So units are taken away. So distance units are taken away. Awesome job, Edgar. I like the way that you're looking at that. That's a good way of looking at it. So distance units, D-I-S-T-A-N-C-E, units are taken away. Very good. Nice job, Edgar. And I like the way that you explain that, because you're like, I don't know if this sounds right, and you took a risk. I love that. Risks are always good to take in math class. Awesome. So now let's take a look at the 3 new vocabulary words that we have been learning. So we learned this idea of a dilation. And a dilation is a transformation in which every point on the figure moves along a line and changes its distance from a fixed point. The fixed point is called the center of the dilation. All the original distances are multiplied by the same scale factor. So if we look at this example that I gave you here, my center of rotation is point O, and I took A, B, C, and I multiplied it by a scale factor of 3. And how can we prove that the scale factor was in fact 3? Or like, what can you say when you look at it that proves that the scale factor could in fact be 3? What happened to it? Sam B, what do you think? So we're looking at shape ABC, right? And we said that we dilated it by a scale factor of 3. How can we be sure that, or what can we say that proves that yes, we could have in fact dilated it by a scale factor of 3? What happened to the shape from the first one to the second one? If we look at ABC, right, what happened to it when we dilated it to this new green one here? What physically happened to the shape? It got bigger. Good. Yes, Rashem. The shape got bigger. So we can say, yes, this could in fact have, very good job, Sam. We could in fact say that this could have a scale factor of 3 because it's a number that's larger than 1 and my new shape got bigger. Very good. Nice job. Awesome job, guys. So now the center of dilation, like I just talked about, the center of dilation is the fixed point on a plane. That's the starting point when you measure your distances for a dilation. So that means when we're looking at, for example, triangle A, the center of our dilation would be point P. So we would find and calculate and measure this distance from each one of my vertices using that P as the center. And then the scale factor, as we know, we talked about this extensively last year in our first unit. To create a scaled copy, we multiply all the side lengths in the original figure by the same number. The number is called the scale factor. So the scale factor on this shape here from going A, B, C to D, E, F would be a scale factor of 1.5 or 1.5. So it's that number, the scale factor is the number you multiply each distance by to get that new figure, that new image. Okay? So ladies and gentlemen, you guys did fantastic today. What we're going to be doing, what you're going to close off the day doing is this exit slip here. Some of you had the opportunity to complete it in class, so you don't need to complete it again. I'm putting it here for the people that didn't get a chance to complete it. So it's first name, last name, cohort number, and we're going to use this circular grid right here to find which point is the dilation of point A using center P and a scale factor of 3. Explain how you know, and use this image. Which point is a dilation of point B using center P and a scale factor of 2. So you're going to take a look and you're going to complete these 4 questions using the 2 images. I'm not saying that's the right answer. That's probably not the right answer, but it just accidentally clicked. If you already completed it though, you don't need to do it again. I just put it here because some friends did not get a chance to complete it in class yesterday. I know just because we had the half day, I didn't get a chance to, with period 2, have you guys work on it. So please make sure you complete that now. Oh, so Sam, I have to, with the typing piece, I have to go in and check it. So I'm going to send it back to you with your final score this afternoon, okay?
I have a question. So tomorrow when we have a half day, how long are our classes?
They're going to be 37 minutes.
Oh, okay.
So it's not like super short. It's not like much shorter. We took a bunch of time off of the encore so that we didn't have to take as much time off of our regular classes. Good question. Awesome. Okay, so if you guys listen, there's a couple. I don't want people to leave yet because I have a few people I want to have stay behind. Let me just. I have a bunch of stuff all over my desk. So these are the people that didn't finish those ones. Okay, so I put grades for the test into PowerSchool. If you are a person that works only at home, so if you're a CVL student, if you want to have a discussion about what you got and why you got it, please send me an email today. And I will be handing back to you guys, if you're in school over the next 2 days, the little sheets that have the score breakdown. And you will have an opportunity to talk to me about that then. So don't be emailing me right now about makeups. I want you to look at the comments that I put on it first, and then we can talk about makeups, okay? Does anyone have questions for me? No? Okay. So you guys can start to head out. Please check Power School for your test grade. There are a few people that didn't complete both pieces, so I wasn't able to put the final score in. So please check your grade in Power School.
Bye.
Bye, Edgar. Awesome job today, my friend.
Have a good day. Bye.
Good one. Bye, Destiny. It was good to see you today.
For the website thing, where you did